Hello friends, today I would like to explain about high performance liquid chromatography. It is a kind of liquid chromatography and it is commonly used for qualitative and quantitative analysis. Yeah, this is a block diagram of Hplc instrument. So Hplc instrument has four different major components. One is solvent system, then injection port, column and dictator. In addition to that, there is a chart recorder or a readout or probably a PC. So these are the different components of an HPLC instrument. In the picture, you can see an HPLC instrument. This is an old instrument. So you can see a readout system here, a chart recorder. So nowadays it is replaced by a PC. Now we will see different components of HPLC system in detail. Probably 80 to 90% of HPLC separations are performed with a pressure of less than 1200 psi. Some polyurethane column material require very low pressure near atmospheric pressure. So now we will see what are the different components. First one is mobile phase supply system. So the solvent should be pure and degassed to avoid the formation of bubbles. Most common way of degassing are sparging with helium, which remove about 80% of air from the solution. Solution in the sense the mobile phase. Or vacuum degassing can also be used, which can remove around 60% of air from the mobile phase. Reciprocating pumps are most commonly used for HPLC, and this pump has a small cylindrical piston chamber that is alternatively filled with mobile phase and then emptied via back and forth movement of the piston and produces a pulse flow. They provide constant flow rate and independent of solvent viscosity or column back pressure. Other than reciprocating pump, motor-driven syringe pumps and constant pressure pumps are also used for HPLC. A typical injection system is shown in the picture. So here the samples can be introduced manually into the valve with a syringe and which will fill the sample loop. So the major limitation of valve injector is that sample size is fixed. If you have to change the sample volume, you have to change the loop. So nowadays, automated sampling valves are commonly used. In this case, samples are taken by auto sampler for unattempted operations. They are actually automated motor driven adjustable syringe that provide enough pressure to inject the sample. Stainless steel columns are commonly used for HPLC. Commonly used stainless steel columns are shown in the picture. They are having very different diameters, but commonly used columns are having a diameter of 3.9 to 4.6 mm. inner diameter. A typical HPLC column with a 4.6 mm inner diameter and particles of 5 micrometer diameter give a plate count in the range of 60,000 to 90,000 per meter at a flow rate of 1 ml per minute. And it is clear that when the particle size decreases, the number of theoretical plates in a HPLC will be increasing. Smaller particles are limited to 25 centimeter length or shorter column because when the particle size decreases, the pack pressure will be increasing. So at 25 centimeter column, 50,000 plates are plausible at a pressure of 5,000 psi with water methanol mixture. A small 3 to 10 centimeter guard column or pre-column is usually placed between injector and analytical column. And this guard columns contains same packaging material as the analytical column. It is placed because of two reasons. First one is it will retain the debris, for example, pump seal fragments and sample particulate matter, etc. So it will prevent the clogging of analytical column. Second reason is it retains highly solved compounds that would be caught on and not to be eluted from the analytical column. So in short, the guard column extends the shelf life of analytical column and it can be replaced periodically. The fourth component of HPLC is dictator, and HPLC system required very sensitive detectors which can sense microgram to nanogram level of analyte. LC detectors include non-specific detectors such as refractive index detector and partly specific detectors such as UV detector and totally specific detectors like fluorescent detector. The sensitivities increase with specific detectors. First one is ultraviolet detector. UV visible detectors are commonly used to measure components showing an absorption spectrum in the UV visible region and have better sensitivity, about 10 raised to minus 8 grams per ml, that is 0.01 ppm level. It is not temperature sensitive and relatively inexpensive and can be used with gradient illusion. It is sensitive to large number of organic compounds. So because of this reason, the UV detector represents about 80% of the measurements made. But it cannot be used with solvent that have significant absorbance in the UV visible region. More expensive detectors have a monochromator that allow selection of a particular wavelength. A UV detector employs a deuterium discharge lamp as a light source with a wavelength of its light ranging from 190 to 380 nanometer. And for visible region, a tungsten lamp is commonly used. The different components of UV visible detector is shown in the picture. So it has a tungsten lamp and a deuterium lamp, and the light from both the lamps will be falling on a diffraction grating. So it will disperse into different wavelengths and also help to select a particular wavelength. For example, when the measurement is performed with a wavelength of 280 nanometer, the angle of diffraction grating is adjusted so that 280 nanometer light can only fall on the sample that is flowing through the flow cell. Here, the intensity of light will be measured before entering into the flow cell and after coming out from the flow cell. From the difference, we can monitor the amount of light that is absorbed by the sample. Next one is diode array detector. Diode array detectors are commonly used in modern HPLC instruments. A diode array consists of series of hundreds of silicon photodiodes positioned side by side on a silicon crystal or chip. Each has associated storage capacitor that collect and integrate the photocurrent generated when photons strike the photodiode. So, in this picture, you can see how a diode array detector works. Unlike UV detector, here you can see the light from both the light source, that is from tungsten lamp and deuterium lamp, is passing through flow cell, and diffraction grating is placed next to flow cell. So the advantage is the entire spectrum can be monitored at the same time. So we will get information over wide range of wavelength at one time, which is a main merit of diode array detector. Next is refractive index detector. This is the first developed detector, and it is also known as universal detector. It measures the changes in the refractive index of eluent that result from the presence of solute as they emerge from the column. So response is depending on changes in the refractive index of eluting compound in the mobile phase. But in this case, gradient elution is not possible. This detector is less sensitive than UV detector. Temperature control is necessary. It is commonly used in size exclusion chromatography. It is able to detect a concentration ranging from 10 raised to minus 5 to 10 raised to minus 6 grams per ml. If the mobile phase is allowed to flow through a hollow prism as shown in the picture, a ray of light passing through the prism will be diverged from its original path and can be focused onto photocell. If the refractive index of the mobile phase changes due to the presence of solute, the angle of deviation of transmitted light will also alter, and the amount of light falling on the photocell will. Other HPLC detectors include fluorescent detector, electrochemical detectors, conductivity monitors, radioactivity monitors, flame photometric monitors, and mass spectroscopic detectors. Thank you.